of this lecture is I will see what is the row equivalent and column equivalent of matrix. Previously in my previous video I have discussed this topic, but today I will discuss what is the row equivalent, column equivalent of matrix geometrically. When two matrices are row equivalent, if you know this geometry, then you will understand the definition of row equivalent, column equivalent in better way. First know the definition. If A and B be K cross L matrices, then we say that A is row equivalent to B if there exists K cross K elementary matrices E1, E2 up to En such that E1, E2 up to En times A equal to B. And today's goal of this lecture, I will see this operation by geometrically. If you know the geometry, what is the elementary operation, why here use this operation, and why I have told these two matrices are row equivalent, column equivalent, then you will understand in better way what is the properties of row equivalent matrices, column equivalent matrices. Okay? Oh well. Actually, today's goal of this lecture is, at first I will say when two linear system of equation be equivalent, then if you know this concept in better way, then you can understand in very easily what is the definition of row equivalent and column equivalent matrix, why this elementary operation has used here. At first I will say to system of linear equation when be equivalent. For this, at first I will say when to system of linear equation be equivalent. Consider any general field, consider f equal to q, r, c or any field, and consider one system of linear equation a11 x1 plus a12 x2 up to a1n xn equal to y1 and a21 x1 plus a22 x2 plus a2n xn equal to y2, and this would be continue, then I will get an1 x1 plus an2 x2 up to anm x n equal to ym. Here n equation m unknowns. Consider this system of linear equation and consider this as name as 1, and we all of us know in numerical I have seen this solution x1 x2 up to xn be the solution of this system of linear equation which belongs to fn, and this solution I will get by Gauss elimination. We all of us know what is Gauss elimination. For this, just see what is the Gauss elimination. I hope my all viewers know this method. At first just recall. Consider system of linear equation Ax equal to b. Here I have considered y1, y2, yn as a b. And for short calculation, for easy to understand better way, I have considered 3 cross 3 system. For this, consider this system of linear equation. Then multiply the first row by a21 a11 comma a31 a11 respectively, and subtract from first row, subtract from second and third row. Then the second equation would be such type a22 here suffix to x2 plus A23 here suffix 2 x3 equal to B2 here suffix 2, where obviously A22 suffix 2 means A22 minus A21 over A11 A12, and A23 suffix 2 means A23 minus A21 over A11 A1 times A13, and B2 here suffix 2 means B2 minus A21 over A11 times B1, and third equation would be reduces A32 here also suffix 2 x2 plus A33 here also suffix 2 x3 equal to B3 here suffix 2, where obviously A32 suffix 2 means A32 minus A31 over A11 A12 and A33 suffix here also suffix 2 means A33 minus A31 over A11 times A13. Okay. Then multiply first row again by 32 suffix 2 over A22 and subtract from second row. Name this equation as 1 and this equation as 2. Then again multiply the first row of equation 1 by A32 suffix 2 over A22 suffix 2 and subtract from this second equation 2. At first multiply this by first equation in 1 and subtract from second equation in 2. Then I will get final equation A33 suffix 3 x3 equal to B33, where obviously this A33 suffix 3 means A33 suffix 2 minus A32 suffix 2 over A22 suffix 2 times A23 suffix 2, and B3 suffix 3 means B3 suffix 2 minus A32 suffix 2 over A22 suffix 2 times A23 suffix 2. Then the original equation would be A11 suffix 1 x1 plus A12 suffix 1 x2 plus A13 suffix 1 x3 equal to B1 suffix 1, A22 suffix 2 x2 plus A23 suffix 2 x3 equal to B2 suffix 2, and here A33 suffix 3 x3 equal to B3 suffix 3. This is the original equation. Have you understood this? As for example, consider this equation and at first eliminate x1 from last two equation. That means multiply at first equation 1 by 3, then subtract from equation 2, and then multiply again equation 1 with by 2 and subtract from equation 3, then I will get x1 plus x2 plus x3 equal to 6, and here from this I will get x3 equal to 2, and from this line after multiplying and subtracting I will get minus x2 plus x3 equal to 1. Now since x3 equal to 2 I have got, just put the value here, then I will get x2 equal to 1 and x1, here I have got x2 and x3, then put the value, then I will get x1 equal to 3. Have you understood this equation? Oh well. By Gauss elimination method, actually we can find the solution of any system of linear equation, and here actually the goal is, our goal is we have to find by the equation, we have to find the value of x1, x2 up to xn. So actually this is the elimination method. Okay. Oh well. Now let's come back our original discussion. I will see when system of linear equation be equivalent. That of Gauss elimination, multiply this equation by a scalar. Then we will get, multiply this first equation by C1. Then I will get C1 A11 X1 plus up to 1 in C1 to, here would be C1 to X2 times, this would be continue, plus A1 in 1 in Xn, plus multiply second equation by C2, then this would be C2 times A2 to X1 plus this would be continue plus A2n Xn, and this would be continue just. Then multiply this equation by Cm, then this would be plus Cm times an1 x1 up to anm xn equal to, this would be c1 y1 plus up to cm ym. Okay, rewrite this equation as c1 a11 plus c2 a21 up to cm am1 times x1. Similarly, this would be c1 a12 x1 plus c2 a21 up to cm am2 times x2, and this would be continue, and last line would be c1 a1n up to cm an mxn equal to c1 y1 up to cm ym. Just rewrite this equation as same way. Obviously, solution of this equation, also solution of this linear combination. Now just rewrite one new equation which is actually linear combination of this equation, and this equation would be such type: b11 x1 times b1m xn equal to z1. This is actually the linear combination of first equation, or bk1 x1 plus up to bkn xn equal to zk. And notice that this equation actually is a combination of this equation. So the solution of this equation obviously would be always solution of this equation, because this is actually the linear combination of first equation. But so here the solution obviously be solution of this equation, but there may be extra solution which cannot be solution of this equation. As for example, consider whole c1 c2 cn is 0. That means obviously this solution would be just 0 solution, but not solution, 0 not be solution here. So every solution here also be solution here, but there can be more extra solution, because here the system of linear equation would be the linear combination of this equation. Okay, that means actual the point is this system might have more solution than the original system. Okay, well, and our goal of lecture is when two system of linear equation be equivalent. Here I have got this system of equation, actually the linear combination of this system of equation, and we can get maybe there exists more solution than the original system of solution. But if we construct this older system, means this system, as a some linear combination, that means these two system, this and this system, new system has same solution, then we can tell this system of two linear equation be equivalent. So if we can to find linear combination of this system by any method, then I will get same solution. Okay, then we can tell these two system actually equivalent. How we will construct this system, this is two system be equivalent? This is our method. So actual definition is two systems are said to be equivalent if they have same solution. And notice is Here combination of this system is written as, this is the combination, linear combination of this system, and here x1 after linear combination, this would be, x1 would be this combination. Here this is different type. For this, what we will do? Consider this equation, obviously x equal to b, where consider capital A is coefficient matrix. That means this would be A11, A1n, up this would be continue, and last column would be, last row would be such type AM1 up to AMN, and this is the M cross N matrix, and B would be Y1, Y2, Ym, and X means X1, X2, Xn. Now we combine this column here, then we all of us know this is actually the augmented matrix, which is order of M cross N plus 1. This is the augmented matrix. We all of us know. Then construct similar way. Here also augmented matrix, and here augmented matrix would be such type A dash B dash. Then obviously here this augmented matrix would be different, because here B11 means here the linear combination of this original matrix. That means here B11 means this part, B12 means this, and B1m means this. That means this is actually the first row of this augmented matrix. That means this matrix would be obviously different. It's the first row of this augmented matrix, and ith row of augmented matrix would be such type, because this is the linear combination of this matrix. This is actually the first row. Actually this matrix would be such type Ci1 A11 x1 plus A12 x2 plus up to A1n xn plus Ci2 A21 x1 plus A22 x2 up to A2n xn. This would be continue plus Cin times AM1 x1 plus AM2 x2 up to AMN xn equal to C1 y1 plus up to CM ym, where obviously this I equal to 1 to up to k. Have you understood this concept? That means similar to first row, here the ith row would be such type. Actually ith row of this matrix would be Ci1 A11 up to A1n. This is actually Bi1. Then Ci2 A21 up to 2n. This is actually Bi2 up to, this is actually Bin. This is the ith row of this matrix, where I equal to 1 to up to k. Have you understood? That means this matrix, this augmented matrix here always be different from original augmented matrix, because augmented matrix means at first the coefficient of the matrix A bar, here A bar is different. So actually this augmented matrix would be P times the older augmented matrix AB, where this P actually the matrix of order K cross M. Okay, so I hope my all viewers have understood. Two matrices A and B are row equivalent and column equivalent, means there exists some elementary matrix E1, E2 up to En times A equal to B, and this is actually, this operation would be such type. Here E1, E2, En means just matrix. Okay, so just recall the similar matrix. I have told you definition of similar matrix. Two matrices A and B are similar. I have seen the definition. If there exists one invertible matrix P such that A equal to P inverse AP. Have you understood why there exists in definition A equal to P inverse AP has used? because of for this. And obviously this P would be invertible. That means we all of us know invertible would be such time when K equal to M, then P transpose equal to obviously identity. What I will do, actually I have given one system of linear equation, then I have multiplied this system of linear equation by scalar, then I have given one new system of linear equation, and here I have got different type augmented matrix, and here the augmented matrix be different, and this new augmented matrix would be same as multiply with one matrix having k row and k row and m columns with the older augmented matrix. Okay, then the solution new and older are same. That means I have got same solution in these two system of linear equation, because I have seen few minutes ago the solution of older system always be the solution of new system, but there may be exist more solution in the new system, linear combination of this system, but when I have multiplied with suitable matrix, suitable invertible matrix P, then now I have got two systems which are actually similar, means they have same solution, older and new system. Have you understood? This is actually the definition of equivalent. This is actually geometry of system of linear, when system of two linear equation be equivalent. This concept actually used to define when two matrix be similar, and also to define the row equivalent, column equivalent matrix. Okay, then consider x bar, x2 bar, xn bar be the solution of the system of linear equation a bar x bar equal to b bar, where obviously x bar means x1 bar up to xn bar. Okay, now multiply this equation by P inverse in both sides, then this would be P inverse times a bar x bar equal to P inverse b bar. Now properties of matrix association, this would be P inverse times a bar times x bar equal to P inverse b bar. Okay, and P inverse a bar means actually, this means actually the P inverse a bar means this matrix A. So just put the value, then this would be a x bar equal to, here P inverse B means B, that means this solution x bar be also solution of the augmented or old augmented matrix A. Have you understood this geometry? I hope my all viewers have understood in better way this geometry. So I hope my all viewers have understood our next goal. What is the row equivalent and column equivalent matrix? If A be M cross N matrix over the field A, then A is row equivalent if A is multiplied with one elementary matrix E, where E is actually the invertible matrix, and this is actually this elementary matrix is nothing but this is actually the row operation. We multiply A with the elementary matrix, then we can tell this would be the row equivalent matrix, and this is actually the row operation. We will get this invertible matrix by row operation. Similarly, column equivalent matrix. I hope my all viewers have understood this geometry. Today I will stop here. In my next video, I will discuss some question of these topics. Okay? But at first I will highly recommend you, please pay attention in today's geometry. If you know this geometry in better way, then you will understand this concept. Have you understood? Okay. Oh well. Thank you so much.